Hi everyone, Namaste. Happy Holi and all. So guys, did you had the opportunity to revise all this? Did you had the opportunity to revise all this? Yes. So, guys, first let us quickly get into some basic aspects and start it. You see, we were talking with respect to atmospheric circulation and guys, you see, atmospheric circulation. We spoke about, yes, ma'am, in climatology, pressure gradient force. What exactly is pressure gradient force? Wind always blows from high pressure to low pressure. Second, we read about frictional force, where we tried to say that as friction increases, speed decreases. Then we studied about gravitational force, where I told that cold air descends. And then we read about Coriolis force, where we said that it turns to the right in northern hemisphere and left in southern hemispheres. The next most important thing that I have to study is, everyone look at here carefully. This is Earth. This is your tropopause. This is your troposphere. This is stratosphere. Guys, can you tell me, in troposphere, if I take A and B, can I say A will be hot, B will be cold? If I take C and D, stratosphere, can I say C is cold, D is hot? Can you tell me which layer will have convection, which layer will not have convection? So in troposphere, will you have vertical movement of air? And in stratosphere, can we say no vertical movement of air? Now everyone look at here carefully. If this is Earth's surface, and if I say Earth is hot, okay, Earth is hot, air rises. Let us assume air keeps rising. Air keeps rising. Air keeps rising. Can you people tell me, can there be vertical movement of air in troposphere? Can there be vertical movement of air in troposphere? Yes, yes. But can this air rise vertically in stratosphere? Can this air rise vertically in stratosphere? No. If it is no, can I say after hitting, will it start diverging, guys? After hitting, will it start diverging? Can there be horizontal movement? Can there be horizontal movement? Yes. Now, can I say vertical movement of air occurs only in troposphere, and by the time it goes to stratosphere, vertical movement of air reduces. Do you agree? Yes. In tropopause, it will be very less now. Now, everyone, please don't draw. Please don't draw. I'll give you time. This is very, very important for rest of geography. I will help you understand it very well. So please wait. Guys, can you tell me normally sun's rays will be vertical over which region? Normally sun's rays is vertical over which region? Equator. Very good. Where will you have less temperature? Poles. Can I say near equator you will have high temperature? Near poles you will have low temperature? Yes. So high temperature will lead to rising of air. Maximum it can reach till tropopause. Maximum it can reach till tropopause. Correct? After tropopause, it will move out. Low temperature means cold air would descend and it would diverge. Guys, can I say high temperature leads to low pressure? Can I say high temperature leads to low pressure? Low temperature leads to high pressure. Wind will blow from where to where, guys? High pressure to low pressure. It will rise. It will rise. And then it will come down. Can I say air, if it rises, it has to circulate and come back? Is there one circulation here? This circulation is called as unicellular circulation. This circulation is called as unicellular circulation. I have a question to you all. Does this occur only in northern hemisphere? Will it also occur in southern hemisphere? Does it occur only in northern or both northern and southern? No. It will happen in northern also. It will happen in southern also. Okay. Now, can you people tell me this high temperature and low pressure? First class I'm asking you. High temperature, low pressure. Is this thermally induced? Is this thermally induced? Yes. You see here near the poles, low temperature and high pressure, is it thermally induced? You see, low temperature, high pressure. Chandru, Rakesh and all, you see, is it low temperature because sun's rays is less? Chandru, Rakesh, is sun's rays less here near the poles? If sun's rays is less, you will have low temperature. If you have low temperature, will it lead to high pressure? Yes. Can you all write with me? You write with me? Atmospheric circulation. Atmospheric circulation. Below this, you write unicellular circulation. Atmospheric circulation. Unicellular circulation. Draw this. Draw this. See guys, I am considering Earth like this. Equator is here, poles are here. Okay, equator is here. I'm drawing a straight line. Gayatri, I'm drawing a straight line. This is equator for you. This is poles for you. Wind will blow from poles to equator, rises and again come back. Is this done? Simran, see first class, ma. I have taught what is thermally induced and dynamically induced. Okay. Guys, even if it is hot or cold, if it is due to Earth's surface temperature, we call it as thermally induced. Okay. Thermally induced doesn't mean only sun should heat. It is not only associated with hotness, it is also associated with cold surface. Ma'am, Anjali, I didn't talk about water going, ma'am. I just spoke about wind. Okay. Are you all done with this? You write with me. Solar insolation. Solar insolation is vertical near equator and it is very less near poles. As equator is heated by solar insolation, we observe high temperature near Earth's surface. High temperature leads to low pressure in the atmosphere, where we observe converging and rising air. Then near poles, near poles, surface is covered with glaciers and surface is very cold. Low temperature surface leads to high pressure in the atmosphere. That is, there will be descending and diverging air. Done? Yes. Due to temperature difference in poles and equator, there will be pressure difference near poles and equator. Wind blow from high pressure to low pressure. Wind blow from high pressure to low pressure. That is from poles to equator and rises near equator, rises near equator. Near equator, it rises almost till tropopause, And as vertical movement doesn't occur in stratosphere, there would be horizontal movement of air. This air reaches poles and they descend. It leads to unicellular circulation model. Okay. Just a minute, guys. Some questions I'll answer. See, Kamal Pal is confused about why air is not rising in stratosphere. I think the first class or second class we said there is no vertical movement of air in stratosphere. So, if there is no vertical movement of air, let us say above this layer, vertical movement is not allowed. Then what happens? Air rises, but it cannot pass through this layer because it cannot go vertically above. As it cannot go vertically above, air after hitting this either has to go like this or has to go like this. And this is what we observe everywhere. Okay. So, if vertical movement is not allowed, you do not have any choice. You cannot come down because air is continuously rising. So, what will happen? It will hit and it will go. This is the basic concept. Second, Anjali is talking about, I'm not understanding Anjali your question at all. A very basic thing what I'm trying to tell you is, if at all 90-degree poles has high pressure, equator has low pressure, wind will blow from high pressure to low pressure. That is from poles to equator. It comes till equator, it rises near equator and circulates back. That's it. I'm talking about entire earth. I'm not talking about land and sea or sea and land. I'm only considering entire earth. Okay. Dayapan, there is no name for that flow. Everyone, is this done? Neelanjana, you're right. Okay. See this. Now you tell me, people. Now you tell me, people. Did we read about Coriolis force? Did we read about Coriolis force? Yes. You tell me, will Coriolis force allow air to go straight, or will it make the air to turn to right and left? Can I say turns deflation? Yes. Now my question to you, everyone for 5 minutes, stop other topic questions, focus on this. Everyone, I want everyone to focus on this carefully. Please don't draw. We need to change a lot of things. See here, I have 90 degree and I have 0 degrees. As you're all aware, Earth's surface is hot, so hot air rises. Hot air rises. Hot air rises. It rises till tropopause. One branch will go like this, another branch will go like this. Near the poles, I have low temperature. Due to low temperature, air will descend and cold air will go. You see, one side I'm getting cold air coming, another side warm air is rising. Okay. Guys, everyone, can you tell me what is the temperature near tropopause? Can you recollect and tell what is the temperature near tropopause? I'm not asking constant and all, I'm asking value. Can I say it is minus 54? Minus 54? Yes. Guys, you tell me at minus 54, will air also become cooler? Will air also become cooler? Air became cooler. Okay. Now, you tell me, will the air go straight or will it go to the right or left based on Coriolis forces? Will it go to the right or left or will it go straight? Everyone, see this. See this carefully. Okay, now, can I say air rises, hits tropopause, it turns. After turning, it should go to the poles. But due to Coriolis force, it turns to the right in the northern hemisphere. If it is in southern hemisphere, it will turn to the left. So due to Coriolis force, it will either turn to the right or it will turn to the left. Can you tell me why air is not going to the pole? Why air is turning to the right or air is turning to the left? Which force is responsible? Coriolis force. Good. Can you tell me when it is going like this, after a while, can you tell me, will air become cold? Will air become cold near tropopause? Yes or no? Huh. So, can you people tell me, if air becomes cold, will gravitational force act on it? Yes. Due to gravitational force, can we say it will start coming down? Due to gravitational force, can I say it starts coming down? I want you to think and tell. Is the air coming down because of Earth surface temperature, or is it coming down because air has become cooler? Can you tell? Is it coming down because air has become cooler, or Earth's surface temperature is cooler? You tell me, if Earth's surface temperature is hot or cold, air rises and descends. That is called as thermally induced. When do you call it thermally induced? When land has to be hot or land has to be cold. If air is hot or cold, and if air comes down, then it is called as what? Dynamically induced. Dynamically induced. Everyone see here. Will the air descend? Will the air descend? Yes. Can you tell me? Can you tell me air is descending due to which force? Air is descending due to which force? Gravitational force. Yes. You tell me, as air comes down, will it start becoming hotter? Yes. Now you tell. Now you tell. Once it hits the ground, once it hits the ground, will it go down or will it diverge? Puja, hotter because 30 degree is hotter. Yes. And once it hits, one branch will go towards this, another branch will go towards this. Now my question to you is, can I say this hot air coming towards equator, will it rise again near equator? Will it rise again near equator? Why does it rise again near equator? Because of Earth's surface temperature. Will it form a circle? Will it form a circle? This circle is called as Hadley cell. This circle is called as Hadley cell. Yes. Now I have another question to you all. Please think and tell. In this part, can you see cold air coming from the poles, hot air coming from the 30 degree? Are they converging in this region? Are they converging in this region? Yes. You tell me, when hot and cold converges, which one will rise? When hot and cold converges, which one will rise? Hot will rise. Okay. Can you tell till where does it rise? Can you tell till where does it rise? Till tropopause. One branch will go towards this, another branch will go towards this. You tell me, near tropopause, after a while, will it become cooler? You see here, is it becoming cooler and coming down? Is it becoming cooler and coming down? Can I call it polar cell? Can I call it polar cell? Yes. Then you see here, air descends, air becomes warmer, and again the process continues. This is called as Ferrel cell. Do you have 3 cells, guys? Do you have 3 cells? Yes. This, yes, Kennedy, it is, this is called tricellular circulation. Now you tell, do you have 3 circles in the northern hemisphere and 3 will be in the southern hemisphere? Yes. Guys, okay. Everyone, help me to name first. Do you have descending and diverging? Do you have descending and diverging? Is it high pressure or low pressure? Is it high pressure or low pressure? High pressure. Can I call it as polar high pressure? Can I call it as polar high pressure? Kavita, what is how, ma'am? Don't you know that descending and diverging air is high pressure? First class only we studied, no, ma'am? Second, can you see here converging and rising? Converging and rising. Can we call it as low pressure? Guys, 55 to 65. It's not exactly 30 degree. It's not exactly 60 degree. 55 to 65. What do you call it as? 55 to 65. What do you call it as? Subpolar low pressure. Subpolar low pressure. Good. Can you tell me this? 30 degree. 30 degree. Is it descending and diverging? Is it descending and diverging? Yes. Can we call it as high pressure? High pressure? Can I call it as subtropical high pressure? Aditya, subpolar is 55 to 65. Now, I have a question to you all. Near equator, everyone, please understand this. Near equator, why is Earth's surface hot? Near equator, why is Earth's surface hot? Due to what, guys? Due to what? Sun. Everyone, do you understand? Sun. Yes. You tell me, is sun's rays vertical only over equator, or will it be vertical at different places at different time periods? Can you tell me March 21st? March 21st, sun's rays is vertical where? March 21st, sun's rays is vertical over equator. Yes. June 21st, sun's rays is vertical over. June 21st, sun's rays is vertical over Tropic of Cancer. Good. September 22nd, sun's rays is vertical over September. See, most of you are giving wrong. This shows you didn't read. Guys, March 21st, sun's rays is vertical over equator. June 21st, sun's rays is vertical over Tropic of Cancer. September 22nd, sun's rays is vertical over equator. December 22nd, sun's rays is vertical over Tropic of Capricorn. Yes. Now, can you tell, is sun's rays vertical over equator, Tropic of Cancer, Tropic of Capricorn? Can it be vertical? Can it be vertical from Tropic of Cancer till Tropic of Capricorn? Can it be vertical from Tropic of Cancer to Tropic of Capricorn? Yes. Can I call it as intertropical? Can I call it as intertropical? Yes. And is it converging? Is it converging or rising? Sorry, diverging. Is it converging or diverging? Converging. So it is called intertropical convergence zone. It is called intertropical convergence zone. Do you understand the four letters? What is it? Intertropical convergence zone. Yeah. See, wherever sun's rays is vertical, earth will be hot. And wherever earth is hot, you will have converging and rising air. Sun's rays is not always vertical near equator. Sun's rays will be vertical near equator. It may go to Tropic of Cancer. It may go to equator. Again, it may come back to Tropic of Capricorn. So, sun's rays will be vertical from Tropic of Cancer to Tropic of Capricorn. Anywhere in this region, sun's rays can be vertical. So this region is called intertropical. And wherever sun's rays is vertical and air is rising, we normally call it as converging zone. Intertropical converging zone. 0, 30° north, 60° north, 90° north. In exam, no need to show different colors, ma'am. In class notes, show different colors. Everyone, I want you to write this down properly, guys. Slowly take your time. I'll give 3 minutes. Even if it is done, take your time, 3 minutes and draw. XY, yes. Simran, yes, ma'am. Very good. It occurs due to Coriolis force and gravitational force. Ferrule is a person who brought it. Parul, yes. Yes, Aditya. 23.5 to 35 is subtropical. Yeah. It's 547 till 550. Sushmit, yes. Nilanjana, intertropical convergence zone. Jay, while writing, you will understand much better. Wait for a while. Yes, Aditi, you can. Yes, same thing occurs at southern hemisphere also. Yes, Abhishek, name of Ferrel and Hadley is this. Scientist names. Mid latitude is 30 to 60. Hadley, Ferrel are names of the people. ITCZ, Intertropical Convergence Zone. Geographers, ma'am. Geographers. Yes, Akshay. Ashish, we will be reading that a lot. Please wait. ITCZ, we will read that. After this, we will read. Simran, we will be doing it, ma'am. Don't worry. Everything I will teach you. Guys, this is mains question which will be asked for 15 marks. Hi, it's okay, Anjali. force only, due to Coriolis force only, they are turning to the right and left. Three pages, guys. Puja, above stratosphere, you will have mesosphere. Kennedy, yes, one is from northern, another one is from southern. Done? Six. Now, please write along with me slowly, properly you write. 15 marks. Near equator, when solar insolation is vertical, earth surface temperature may become very hot. As earth is hot, air above the earth also becomes hot, and hot air rises. It rises till tropopause, and it diverges. Near poles, solar insolation is less and surface is covered by glaciers. Due to this, low temperature is near surface and high pressure in atmosphere, where there will be descending and diverging air. Yes, Jay, it is similar in southern hemisphere also. Guys, I'll move to next page. Cold air from poles move towards equator. Near equator, the hot air which diverged near tropopause, the hot air which diverged near tropopause will move towards northern hemisphere and southern hemisphere. Due to Coriolis force, this upper air doesn't reach poles. They deflect towards right in the northern hemisphere and left in southern hemisphere. Moreover, as temperature near tropopause is very cold, air becomes cold and denser. Shall I move to next one? You see, the cold and dense air descends due to gravitational force. Gravitational force. The air is descending not because of surface temperature, but because of air temperature. The descending air would become warmer due to adiabatic heating or friction. This air descends in between 25 degree to 35 degree north or south. As it hits the ground, it diverges, where one branch moved towards equator and another branch towards poles. Done, guys? As air descends and diverges, it is dynamically induced high pressure, and as it occurs in between 25 to 35 degree north or south, it is called subtropical high pressure. It is called subtropical high pressure. Next, from subtropical high pressure, hot air diverges towards equator and it rises near equator and forms a circulation This circulation is called Hadley cell, which is in between subtropical high pressure and ITCZ. Intertropical convergence zone. Intertropical convergence zone. Daipan, I will be teaching you ITCZ again, don't worry. Is this done? Next. Another branch from subtropical high pressure would move towards poles. From poles, we observe cold and dense air diverging towards equator. Cold wind from poles converge with warm wind from subtropical high pressure in between 55 to 65 degree north or south. As warm and cold air converges, warm air is lighter and it rises. Warm air is lighter and it rises. As warm air rises due to convergence in between 55 to 65 degree north or south, it is dynamically induced low pressure. Yes, Anjali. Yeah, Aditya, you're right. Pooja, there is nothing called like okay, if you're asking, ma'am, 10 degree means 1 degree is 111 kilometer, 10 degree means 1110 kilometers. Everyone, are you done? This low pressure is called subpolar low pressure. Full stop. The air rising near subpolar low pressure hits tropopause and diverges. One branch diverge towards equator and other towards poles. The branch moving towards poles will become cold and descend near poles. This leads to high pressure. It is called polar high pressure, and again air diverges. The circulation in between polar high pressure and subpolar low pressure is called polar cell. Guys, 15 marks, guys, you have to write at least 3 pages. If you don't want notes, puja and all, I'm very happy to not give. We know how during season it changes, we will tell. Not at written, ma'am. Akshay, cold air, if it comes down, then also it is called dynamically induced. I'll move to next one. From subpolar low pressure, air rises and diverges towards equator. During this, air becomes cooler and it converge with Hadley cell and descend. This descending and diverging leads to subtropical high pressure and the circulation completes. This circulation between subtropical high pressure and subpolar low pressure is called Ferrel cell. Done? Guys, I want to ask you a few questions. See, guys, uh, don't worry about the syllabus. I will complete every word in the syllabus because all this from now will be moving faster. We completed the topics easier. So don't worry about it. Second thing, what I want to ask you is, uh, are you people feeling comfortable with the diagrams, guys? Are you people feeling comfortable with the diagrams? Will you be able to draw them? Will you be able to draw them? Will you be able to explain them? Will you be able to explain them? Yes. See this. Let me tell you this. Many students are texting me about the optional. Okay. So let me tell you very clearly. I wanted to wait for this particular day. If you people can draw these and without seeing, if you can draw and without seeing if you can explain them, no one can cut marks. You will definitely score very well in geography. Sir, my diagrams are difficult. I can't draw diagrams. I am very bad at it. I can't elaborate it. Then geography as an optional is difficult. Guys, as I told you, I'm teaching you at optional level. Don't think GS only to this depth, optional to what depth it would be. No. This is the maximum depth you can have. Whatever answers you can write for optional, I'm giving same concepts, right? So that any question in prelims is also easy for you. So, in case if you have confusion, until now, if you have clarity of the things, there will be students who are not comfortable. That's always fine. From GS point of view, if you can by heart, that's enough. But those people who have understood every concept here, If you people feel, you can rewrite them. This is the optional you can choose. Feral is the name of a person, guys. Yeah, Aditya, that will do later. Everyone, everyone, look at this now. Guys, everyone, everyone, please don't draw. Look at this carefully. Everyone, this is 90° south. This is 90° north. 5°, okay. 5° north, 5° south. 25° north, 35° north. 55° north, 65° north. 25° south, 35° south. 55° north, 65° sorry, south, 65° south. Okay. Guys, everyone see here carefully. 5° north to 5° south is called ITCZ. Guys. Here it is called subtropical high pressure. Subtropical high pressure. Subpolar low pressure. Subpolar low pressure. Polar high pressure. Polar high pressure. Okay. Everyone see here. Please see, later you can draw. See guys, air rises. Near equator, air rises. One branch will go like this, another branch like this. Air descends. Near the poles, air moves like this. Air descends. Air descends. The air will move like this, converge and rise. Converge and rise. Converge and rise. hits tropopause. One branch comes like this. One branch comes like this. Another branch move like this. Another branch move like this. If you take, this will be your Hadley cell. This will be your Hadley cell. This will be your Ferrel cell. This will be your polar cell. This is your Ferrel cell. This is your polar cell. Next, I want you people to tell me, wind always blow from where to where it is? Wind always blow from where to where? High pressure to low pressure. Good. Can you all see this and tell? Can you all see this and tell? Will the wind blow from subtropical high pressure to ITCZ or ITCZ to subtropical high pressure? Subtropical high pressure to ITCZ. Subtropical high pressure to ITCZ. Good. Here you see, the wind will blow from high pressure to low pressure. 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 Everyone, do you recollect this right and left? This is right, this is left, this is right, this is left. Guys, southern hemisphere, is it left or is it right, guys? Left. Everyone see this carefully. Southern hemisphere, it is to left. This is left. This is left. Okay? Everyone see this? This is left. Do you all agree? See this? This is left. Wait, Jay. Then northern hemisphere, this is right. This is right. This is right. Guys, everyone, first draw this. Don't get confused. I didn't explain anything yet. Please wait. I will explain. But I want you to write down first. Guys, everything I will explain. Please draw once this. Okay? Please draw this. I'll explain everything in detail again. Today we will be discussing this topic in detail. Okay? So you take 5 minutes to draw and then take breaks. We'll meet at 6:45. Everyone, everyone, did you understand this part of the diagram, guys? This part of the diagram? Now, now, everyone, see here. I have ITCZ, which is 5 degree north to 5 degrees south. And I have 25 to 35 degree north, which is your subtropical high pressure. You see here, guys, north, south, west, east, northeast, northwest, southeast, southwest. Guys, remember, wind is always given name on the basis of from where to where wind will blow. That means if wind is blowing from west to east, we name it as westerlies. If wind is blowing from east to west, we call it as easterlies. I repeat, if wind is blowing from west to east, it will be westerlies. If wind is blowing from east to west, it will be easterlies. So the origin will always be considered. Now everyone, you see, wind here will blow from high pressure to low pressure. We are in northern hemisphere. Can you tell me, will it be right in the northern hemisphere or left in the northern hemisphere? Right. Can I say this is right? Now guys, you tell me, near equator, is Coriolis force maximum or is it zero? Zero. Good. See, if Coriolis force was maximum, the wind would have gone like this. The wind would have gone like this. But as Coriolis force is zero, the wind is going like this. That means the wind is blowing from northeast to southwest. You see, the wind is blowing from northeast to southwest. Can you tell me, should I name it as northeast winds or should I name it as southwest winds? What is the name that I should give? Northeast. Why? Because wind is always named on the basis of where it starts. So this is called as northeast. And guys, earlier these winds were helpful in trade. So it is called as northeast trade winds. This is known as northeast trade winds. Second, everyone, can you tell me here? Subtropical high pressure. 25 degrees south to 35 degrees south. Wind will blow from high pressure to low pressure. Is it left in the southern hemisphere? Now you see, it blows from southeast to northwest. Southeast to northwest. What should I name it as? What should I name it as? Can I name it as southeast trade winds? Yes. I'm sorry. Guys, did you understand this? Did you understand this? Yes. Now my point is, in which cell, are you observing northeast trade winds and southeast trade winds? Yes. Which cell are you observing? Hadley cell and yes, Hadley cell. Okay. Another question to you all. Wind means is it surface winds, advection, or is it convection? Wind means advection or convection? Wind means what? Advection. Yes. Guys, everyone see here. Can I say this is called wind? Horizontal movement is called as wind. Is this wind? Everyone? Can I call this as northeast trade wind? Can I call it as northeast trade wind? Yes. Now, can you draw this? Can you draw this? Guys, draw slowly. See, I'm not wasting your time by talking unnecessary things. We are only discussing about class. I don't crack any jokes. Like, there is nothing about me or asking you. Right? Anurag, it would have been easterlies if it was above. If it was above, Coriolis force. No. Anurag, that is northeast trade wind. I'll come to that. Easterlies, westerlies, I'll come. Aditya, thank you. Hayat, we will see how these will converge. Is this done, everyone? Is this done? Then this. You see, This is my subtropical high pressure, and this is my subpolar low pressure. Subtropical high pressure, subpolar low pressure. Wind will always blow from high pressure to low pressure. High pressure to low pressure. Guys, can you tell me, as I move towards poles, can I say that as I move towards poles, can I say that Coriolis force increases? Coriolis force increases. Can I say that it turns almost straight like this? This is right in the northern hemisphere. This is left in the southern hemisphere. Can you people tell me, is it blowing from west to east or east to east or east to west? West to east. So these winds are called westerlies. Sony, is it? Are you understanding now, ma'am? Please write this. Yeah, guys. Everyone, see here. The winds almost move like this, guys. They don't curve much. They don't curve much. That's why we call it west to east. Twenty-five to 35, 55 to 65. 25 to 35, 55 to 65. Done, everyone? S- 90-degree north till 55-degree north to 65-degree north. This is your polar high pressure, subpolar low pressure. 55-degree, sorry, 55-degree to 65-degree, 90 degrees south. Now, it will be right in the northern hemisphere, it will be left in the southern hemisphere. Can you people tell, is it moving from east to west? So it is called polar easterlies. Polar easterlies. Now do you understand the diagram? No, just write them for references. Exam, you need not write all this. Okay. Everyone, can you tell the three pujas? Wind never blows according to sun. Wind blows according to high pressure to low pressure. Chandru, it starts from south, but most of the winds will blow from east to west. So we call easterlies. Guys, what are the three winds you saw? What are the three winds you saw? Can you tell? First, within Hadley cell, you saw north, east, and southeast trade winds, correct? In ferrule cell, we have westerlies. In polar cell, you will have polar easterlies. Guys, please understand, these three winds are called as planetary winds, or it is called as primary winds. These three winds are called as planetary winds or primary winds. Okay, now you see everyone. You see, you write along with me. Pressure belts and temperature belts. Guys, ITCZ, subtropical high pressure, subpolar low pressure, polar high pressure, they are called as temperature belts and pressure belts. So everyone, First one is called as ITCZ. ITCZ. It is called Intertropical Convergence Zone. Now, I want everyone to see this carefully. First, see, I'll give you time to draw. 5 degree north, 5 degrees south, this is equator. Everyone. Can I say on March 21st and September 22nd, is sun's rays vertical over equator? Yes. Due to this, can you tell me, will Earth become very hot? Will Earth become very hot? Yes. If Earth is hot, will air above the Earth also becomes hot? Yes. Now I have a question to you. Think and tell. Is air becoming hot due to sun's rays, or is air becoming hot due to Earth's surface temperature? Is it becoming hot due to sun's rays, or is it becoming hot due to Earth temperature? Guys, please understand. Earth is becoming hot because of sun's rays. Atmosphere is becoming hot because of Earth's temperature. Do you all agree? Kamalpal and all, do you agree now? You see. Yes. Now my point is, I have land, I have water. Okay, I have land, I have water. Can you tell which one becomes hot sooner? I have land, I have water. Which one will become hot soon? Land. So you tell me, northern hemisphere, southern hemisphere, where do you have land more? Where do you have land less? Northern hemisphere has more land, southern hemisphere has less land. Good. Now my point is, if land is more in northern hemisphere, can I say northern hemisphere will be hotter compared to southern hemisphere? Can I say northern hemisphere will be hotter compared to southern hemisphere? Yes. If northern hemisphere is hotter compared to southern hemisphere, can I say ITCZ is present mostly in the northern hemisphere compared to southern hemisphere? Yes. Now, I want you to think and tell this. I have wind blowing like this. I have wind blowing like this. If wind is blowing like this, can you tell, will the surface heat the wind? Will the surface heat the air? Yes. Will the air become hot? Yes. And what will happen? Can I say the hot air rises? Yes. Can you people tell me, in this region, in between this region, Will you have more air or will you have less air? In between this region, will you have more air or will you have less air? Less air. Guys, in this region, we have low pressure. Low pressure is because of less air. Guys, in this region, air is so less that even air sound is not heard. Right? Air is so less that even I can't understand air breeze. That region is called as doldrum. What is doldrum? It is an area within ITCZ where you will have a region of calm. A region of calm where even wind sound is not heard much. 5 degree to 5 degree, you will have doldrum. Second, can you people tell me, will you have zero air or will you have less air? Will you have zero air or will you have less air? Less air. Okay. If you have less air, can I say the air near the equator, will Earth move from west to east? Everyone, will Earth move from west to east? Yes. Along with the earth, can I say the less air will also move from west to east? Along with that, can I say the less air also moves from west to east? Okay. If air is blowing from west to east, what do you call it as? Will you call it as westerlies or will you call it as easterlies? Westerlies. Good. Do you have westerlies already? Yes. In which cell do you have westerlies? Ferrule cell. Can I say again, if I name it westerlies, it will be confusing. So we use the term equatorial westerlies. Can you tell me equatorial westerlies is within ITCZ? Do you agree? Equatorial westerlies is within ITCZ. Guys, are you understanding the terminologies? Yes. Can you draw this? Kennedy, doldrum basically means you will have very little air. As air is very little, you will not have even the sound of air. That is called doldrum. Yeah, Aditya, equatorial westerlies are actually a presumption. That's why it is not a planetary wind. It is a presumption that along with the rotation of the earth, some wind is also moving. Earth rotates from west to east, Ankita. So we say that is also moving from west to east. Did you draw this? Nilanjana, wait for a while. Here you can add equatorial westerlies. Anurag, Anurag, see, ITCZ is associated with hot surface of the land. Okay, hot surface. So if you have more land, the earth surface will become much hotter. Northern hemisphere has more land. So northern hemisphere will become much hotter. Wherever high temperature is there, ITCZ will be present there. So ITCZ is not near equator, but ITCZ will be mostly above equator because land is more in the northern hemisphere. Yeah. Okay, near equator, if wind is blowing from Kennedy, wind is blowing from west to east, do we call it as westerlies? Yes. If it is near equator, can I call it as equatorial westerlies? Vivek, I didn't write low pressure near poles. Near poles, we have high pressure. Everyone done with this? Can we write? See, guess one question will come on ITCZ. One question will come on ITCZ. Application of this. So it's very, very important for us. Did you all write this? Shall I move? Yes, Aditya, yes. Everyone. See here carefully. Kennedy, Earth rotates from where to where? I don't know why you're getting confused. Earth rotates from where to where? West to east. It appears that wind is also moving from west to east. So it is called westerlies. Okay? Yes. Prelims. Yes. Everyone see here? ITCZ is intertropical because Earth surface is hot in between 23.5 degrees north to 23.5 degrees south due to solar insolation in different seasons. Solar insolation is different on different regions due to revolution of Earth in tilted axis. ITCZ doesn't shift only because of solar insolation, but it shifts because of Earth surface temperature. Earth surface temperature. Shall I move to next one? Earth surface temperature depends on distribution of land and water. On distribution of land and water. If land is more, then it gets heated soon and temperature increases. If water is more, then it takes time to get heated. As northern hemisphere has more land, it gets heated soon. Yes, Pooja. So ITCZ is present mostly in northern hemisphere. Everyone, if they ask you why ITCZ is present in northern hemisphere, what will you tell? What will you tell? Land is more in the northern hemisphere. Do you understand? Land is more. See guys, anytime, if they compare northern hemisphere with southern hemisphere, the answer will be land is more in the northern hemisphere and less in the southern hemisphere. Are you getting the point? Yes. Aditya, that's fine. Interchangeably, if you use, that's fine. Absolutely fine. Yes. Then, whenever ITCZ is near equator, then within ITCZ, we observe region of calm called as doldrum. Called as doldrum. Next. Within doldrum, we observe wind blowing from west to east along rotation of the earth, called as equatorial westerlies. El Nino, La Nina, and all I'll explain, ma'am. I'll explain all that one after the other. Today's class, every day's class, if you understand, that is more than enough. Yes. Yeah, yeah, Aditya. Done with this, everyone? Yeah, Kennedy, we didn't do El Nino and all. I'll teach them later. That's what I'm telling. If you focus on today's class, it's enough. See, guys, as Jai is telling everyone, can I say, can I say, first few lectures initially they were a bit technical. First few lectures initially were a bit technical. But those technical words, are you becoming comfortable now? Are you getting those things now? Yes. Do you understand the importance of those? And now, can I say we are moving faster because of these? It is more about writing with clarity. Whatever UPSC gives you question, you must be able to answer. You cannot say in geography you don't know. That is my intention. Do you understand? In geography, anything that they give, conceptually you have to answer. Yes, yes, Karthik. Everyone. Then we have subtropical high pressure. It is dynamically induced high pressure. It is dynamically induced high pressure because air descends as it becomes cooler. Air descends as it becomes cooler. Next, it is in between Hadley cell and Ferrel cell. Kennedy, you tell me. Hmm. You people are confusing again. You see, whenever land is cold, whenever land is cold, and air above the land becomes cooler. So what is going to happen? Land is cold, air above the land will become cooler, and the cold air comes down. So if air is becoming cooler because of Earth's surface, then it is thermally induced. If air is becoming cooler not because of Earth, but because of adiabatic process or something, then if it comes down, then it is dynamically induced. Now it is also called as horse latitudes. It is also called as horse latitudes. I'll explain why it's. See guys, let us say you had wind descending and diverging. Okay. Now you tell me, earlier, people used to go in the ship by doing by themselves, no engines and all. Today, because of engines, you can move easily. Pressure doesn't matter. But earlier, it was mainly because of man towing the boat. Now my point is, if the ship is coming here, if there is lot of pressure from above, is it easy for the ship to go or is it difficult? It is very, very difficult for the ship to move. Now, earlier, people used to go, you see here, earlier people used to go from Europe to North America, Europe to South America, they used to go. Now, when they used to go, they have to cross these subtropical high pressure. Subtropical high pressure they used to cross. And remember, earlier there were no bikes and all, no trucks, no bikes. Horse was medium of transportation, right? As soon as Europeans get down into North America, they used to take horse and then move. Horse was a medium of transportation. So what they used to do, they used to carry horses also along them in the boat. They used to carry horses also along with them in the boat. And whenever they used to come near this area, they used to feel that as there is high pressure, they didn't know high pressure and all. The ship was not moving. They thought horses have eaten more. Has horses has eaten more, the ship is not moving much. So what they used to do, they used to throw few horses into the water. If they throw horses into the water, normally the ship will become lighter, and they use it to go. As they use it to throw horses near this area, it is called horse latitudes. No one will ask you anytime the story, okay? No one will ask you anytime the story. Jemima, obviously, if you throw horse into water, horse will die. Not even for prelims. Not even for prelims. Just story. Next. Next. Nowadays, no, ma'am. Nowadays, no. You don't have anything of that now. Everyone, you right? Yeah. So many people are telling story is interesting. See, that's the problem. What is interesting, UPSC never asks. What is not interesting is what UPSC is interested in. Okay. So, subpolar low pressure. It is dynamically induced low pressure. It is dynamically induced low pressure because air is rising not because of earth surface temperature, but because of convergence between cold air and warm air. As warm and cold air converge, warm air rises. This phenomena leads to formation of fronts. So, this is called frontal zone. Guys, front is a region where warm and cold air mass converges. Front is a region where warm and cold air mass converges. Yes. Done? Next. Last. It is in between polar cell and ferrule cell. It is in between polar cell and ferrule cell. You have polar high pressure. Polar high pressure. Geographers argue that it is formed due to surface temperature and few others argue that it is formed because above air became cooler. So, geographers argue that it is both thermally induced and also dynamically induced. Guys, different geographers tell it is because of different reasons. So we say it is both thermally induced and also dynamically induced. From polar high pressure, we observe cold air diverging. Sai, in the first two classes I have taught thermally induced means temperature based, dynamically induced means air based. So please look into that once. Done with this, can I move to the next one? Anjali, no. Thermally induced, you are right. Dynamically induced means air becomes hot or cold irrespective of Earth's temperature. Okay. Air becomes hot or cold irrespective of Earth's temperature. That is dynamically induced. Next. You right? Hadley cell. Hadley cell. It is in between subtropical high pressure and ITCZ. In northern hemisphere, we observe north-east trade winds, and in southern hemisphere we observe southeast trade winds. Next, ferrule cell. It is in between subtropical high pressure and subpolar low pressure. Westerlies are present in this region. Polar cell. It is in between polar high pressure and subpolar low pressure. Polar easterlies are in this region. Done, everyone? No, no, Patan, we have climatology is still there. Next, guys, quickly. Next chapter name is winds. Under climatology, next chapter name is winds. Horizontal movement of air is called wind. There are three types of winds. First one, primary winds or planetary winds. secondary winds no, Ankit, you can't call latitudinal. Even if it is longitudinal, we will call it wind only. Horizontal is wind, that's it. Tertiary winds and local winds. See, guys, after winds, I will teach you ocean currents. After ocean currents, I will teach you world climate. After world climate, we will be seeing cyclones, Indian climate. And till Indian climate, if we cover, half of geography will be done. Geography is difficult only in climatology. I take almost, I take almost, what do you call it as, half of the lectures only for climatology. Yes. Is this done? Next. You right? Primary winds or planetary winds. First one, wait. These are the winds which are present throughout the earth in between specific latitudes. First one, trade winds. Trade winds. Within Hadley cell, we observe trade winds blowing from subtropical high pressure till ITCZ. These are northeast trade winds in northern hemisphere, southeast trade winds in southern hemisphere. Everyone done? Shall I move? Please be fast. We'll complete these three. Guys, I want you to bring plain world map tomorrow, guys. Yeah, plain world map I want you to bring tomorrow because we will be dealing with ocean currents. Okay. 3 4 you keep. 3 4 you keep. Second. Anything your wishes. Westerlies. Everyone, quickly can you open world map? Quickly can you open world map? Yes. Guys, can you see 30 degree to 60 degree in the northern hemisphere? Guys, 30 degree to 60 degree in the northern hemisphere. Yes. Do you have land everywhere? Do you have land everywhere? Can I say mostly land? Southern hemisphere, can you see 30 degree? 30 degree. Does it pass through South America? Does it pass through South America? Does it pass through Africa? Does it pass through Australia? Yes. 40 degree, can you see passes through South America? Doesn't pass through Africa, passes through Australia. 50 degree, can I say passes only through South America? 60 degree, can I say passes below South America? Can I say, everyone, northern hemisphere land is more? Do you all agree with me? Northern hemisphere land is more. If land is more, can you tell me, will friction be more or will friction be less? If land is more, friction is more or less? More. If friction is more, speed is more or less? Speed is more or less? Less. Okay. In southern hemisphere, can I say wind speed is more? In southern hemisphere, wind speed is more, everyone? Yes. UPSC asked in prelims, why westerlies are faster in southern hemisphere? What is the reason? Water is more in the southern hemisphere. Do you agree? Land is less or water is more in the southern hemisphere? Yes. Second, can I say, guys, 30 to 40, 40 to 50, 50 to 60, is land decreasing? 30 to 40, 40 to 50, 50 to 60, is land decreasing? If land decreases, can we say speed increases? Speed increases. Yes. Can you write with me? Westerlies. They are surface winds in between subtropical high pressure and subpolar low pressure. That is 30 degree north or south to 60 degree north or south. They are part of ferrule cell. They are faster in southern hemisphere compared to northern hemisphere because land is more in northern hemisphere and friction is more. Land is more in northern hemisphere and friction is also more. In southern hemisphere, westerlies are known as roaring 40s, furious 50s, shrieking 60s. Roaring 40s, furious 50s, and shrieking 60s. Do you understand? Do you understand why? Chandru, Chandru, please understand. If land is more, mountains, plateaus, and all will be more, right? Mountains, plateaus, and all will be more. So wind will hit the mountain plateau, it reduces the speed. Everyone done? Everyone done? Shrieking, Schreiking, Schreiking, shrieking 60s. Yeah. Last is, last, sorry for delaying, please let's complete it. Polar easterlies, they are present within polar cell. They blow from polar high pressure to subpolar low pressure. They carry snow from poles. They blow from east to west. Guys, this is planetary winds, guys. This is planetary winds. Tomorrow, I'll try to complete winds and start with other things. Fine. Yeah, just read class notes for today, guys. Don't read anything else.